Hello everyone. Today we are going to discuss regarding the design of the vertical flow sedimentation tank. Also we are going to discuss regarding the concept of Clariflocculator and concept of tube and plate settler. Now these three concepts are there. Today we are going to see, and these are practiced in the advanced water treatment plant to get the necessary results. Vertical flow type sedimentation tank. The vertical flow type sedimentation tanks are generally in circular shape and flow takes place in vertical direction. Hopper bottom is provided at the bottom of the tank to dispose the collected sludge. Hopper bottom tank. In this hopper bottom tank, a deflector box is located at the top which deflects the influent coming from central pipe to downwards. Sludge is collected at the bottom and it is disposed through sludge pump. Now you can see this is a hopper bottom tank. Okay, so here the various parts are there. Okay, you can see here the at the top the launders are provided here. Then this is the inlet pipe. Okay, so the water moves here like this. This is the sludge pipe, which is to for the removal of the sludge. This is the sludge sump. So it is a hopper is there. So water comes here, okay, and it moves like this, like in the upward direction, and from the this is the effluent channel is there where the water which is a clear water content which is taken and the sludge is removed from this particular point. Okay, so the many arrangements are there uh, uh, to get this particular result in the vertical flow. So why it is called as a vertical flow? Because it flows like this. Okay, it comes, the water comes like this and flows in the upward direction. Okay, so let's discuss regarding the flocculator now. Clarifier and the flocculator are provided in the single unit. Those are called as a clariflocculator. The flocculating chamber is provided in the center and the clarifier component is formed by the peripheral space. Velocity of flow water around 0.3 minute per 3 meter per minute. Mechanical scraper is provided to remove the sludge. Now you can see this is a typical cross section of a clarificator is there. Okay, this is the central unit which gives the rotation. Okay, for this particular sludge scrap arm, right? It continuously moves, and you can see this is the decanting trough for the outflow. So which is the water which is a clear water which is taken from this particular. It is throughout. If you this section is a circular, so it is also is a circular, which is a, this is a cross section. So this is the inlet of the water. Okay, so sludge is removed from this collection tub here the sludge removed is pipe is you can observe here. Okay, so in the plan it look like this. So this particular unit keeps on moving, right, and you can see this particular sump, clear water sump is there here. For the effluent, the water is taken from that. Okay, so and the cross section is like this at the sloping at the bottom you can see. Okay, then tube settler system for clarification, the clarifying system. Tube settlers are and the parallel plates increase the settling well capacity of circular clarifiers and or rectangular sedimentation basins by reducing the vertical distance. A floc particle must settle before agglomerating to form a larger particle. Tube settlers use multiple tubular channels sloped at an angle of 60 degree and adjacent to each other, uh, which combine to form an increased effective settling area. This provides a particle settling depth that is significantly less than a settling depth of conventional clarifier, reducing settling times. Okay, so you can see this is the a cross section of uh, a tube settler. So where the this is a floc zone, the water enters here. Here the quiescent zone is there. Here the vapor is provided, and again the tubes are provided here at the inclined position. Tubes are provided. So because of this, if this is the movement of the water, if this is the movement of water, so this because of these tubes, the particles which are not settled earlier, those will get settled and they will come down. Okay, and this is the settled solids, and these are removed, and the clarified effluent that is taken out from here. Okay, the clear water. Okay, so the simple operation is there here. What is important in tube settlers? We are using tubes for the increasing the settling phenomena. Okay, tube settlers capture the settleable fine flocks that escapes the clarification zone beneath the tube settlers and allows the larger flocks to travel to the tank bottom in more settleable form. The tube settler channel collects solids into a compact mass which promotes the solids slide down the tube channel. Okay, now you can see tube settler versus conventional settling. This part is only showing that the conventional, where in the sedimentation tank, what we are doing, we are only keeping the water stagnant for some time. It is called the detention period. Only so where we are try to see these various particles will settle down here, but rate of settling down it is very slow, right? So it is a problem there that will be if you are only using a plain tube settler, or sorry, only conventional settling, so it will take a long time to settle down the particles. So to accelerate that, you are providing tubes. You are providing the tubes. So because of the tube settlers, the particles settle down fastly, and you are going to get the clear water finals. Okay. So here this phenomena is shown here, how it is accelerated. So in the case of the without tube settlers, the this rate is low, right? Particle settling velocity is also low, but when you are using the tubes, okay, it accelerates. Okay, so this is the advantage of the tube settlers. Now why tube settlers again? So I will repeat the same. Tube settlers offers an inexpensive method of upgrading existing water treatment plant clarifiers and sedimentation basins to improve performance. They can also reduce the tankage or footprint required in new installations or improve the performance of existing settling basins by reducing the solids loading on downstream filters. These are made of lightweight PVC. Tube settlers can be easily supported with the minimal structures that often incorporate the effluent trough supports. They are available in variety of module sizes and tube lengths to fit any tank geometry with custom design and engineering offered by the manufacturer. So very simple to install as well. They are available in the various configuration depending upon the manufacturer, and many modified sections are available. Ready-made sections you can fit in the tank. So very interesting engineering. So you can see this is the one of the section. So the various material can be used for this. It is a typical tube settler. So directly like these sections are fixed in the tank, and the required phenomena is observed. And so in the country there are many water treatment plants are there where the tube settlers are used as a innovative mechanism where the this settling phenomena it is effectively obtained by using these tube settlers. Now, what are the advantages of the tube settlers? The advantages of tube settlers can be applied to a new or existing clarifier basis of any size. Okay, clarifier bases or basins equipped with tube settlers can operate at 2 to 4 times the normal rate of the clarifiers or basin without the tube settlers. It is possible to cut coagulant dosage by up to half while maintaining a lower effluent turbidity to the treatment plant filters. Less filter backwashing equates to significant operating cost saving for both water and electricity. New installations using tube settlers can be designed smaller because of the increased flow capability. Flow of existing water treatment plants can be increased through the addition of tube settlers. Tube settlers increase allowable floc capacity by expanding settling capacity and increasing the solid removal rate in settling tanks. So very conclusively we can say that the here the solids removal rate that is more in case of the tube settlers. Now again we'll proceed further now. Instead of the tube settlers, now inclined plate settlers are also there. Generally the lamella principle is used. Now what is lamella principle that we'll see. The two basic criteria for gravity settling equipments are good clarity of overflow liquid and maximum density of underflow solid discharge. The area required to clarify a suspension is often greater than that needed for thickening. This means that a cylindrical thickening tank, the lower section with rakes and drive mechanism can be oversized. The lamella principle uses several parallel inclined plates to maximize the available settling area for any available floor area. In this way, the size and cost of gravity settler can be minimized by matching the clarifying and thickening requirements more closely. Now you can see here these different plates, inclined plates are placed at an angle. So two forces are acting on this every particle, right? The particle between the lamella plates, these are called as the lamella plates. Uh, this particle between the lamella plates migrate to the each plate surface along the resultant vector of the two forces as the one is the this F1, one is the F1 which is a called as a fluid drag, and another is a FG which is the gravity. Okay, so once on the plates the particle slide down to discharge into the thickening zone. So because of this interparticle collision they settle down at the bottom. The inclined plate settlers, generally called as IPS, consist of two main components: the upper tank containing of the lamella plates inclined at 55 degree and lower conical or cylindrical sludge tank. The fill tank for the IPS enters through vertical chambers on either side of the lamella packs and passes into each plate gap through a slotted feed ports. Clarification takes place above the suspension inlet, so there is no mixing of the clarified fluid with the incoming feed. Above each pack is a full length overflow launder fitted with throttling holes to create a slight hydraulic back pressure on incoming feed stream. This method of feed control guarantees equal distribution of lamella chambers with minimum turbulence at the entry points. Okay, so uniformity is maintained there. The solids settle onto and slide down each lamella plate to the sludge tank where the solids are further thickened and compressed with assistance of the raking system. So raking system is there which moves all these sludge, okay, and it is taken for the further operation. Now what are the advantages of this system? Heavy duty construction of a tank, sludge hopper and lamella plate packs as well as the rake system, rake lifting mechanism as an option, positioning of specifically designed ports for optimum ratio between clarification and thickening area, wide spacing of the lamella plates to handle high density fluid pulps or core solid particles, no short circuiting or surface turbulence, integrated flocculator with variable speed stirrer, lower installation cost, delivered as a one piece unit or prefabricated sections. Okay, so these are you can assemble it together. Smaller foundations required less for floor spaces there, and square outline for easier planning and the construction. So these are all advantages of the this system. Now you can see here a combined unit of this, right? So where you can see these various parts there as a starting from the point 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? So one is the, now this is a huge tank, remember it is seems to be smaller here, but huge tank is there, combination of this. So initially the water will come here, feed inlet. Sec, at the same time you can see the 9 number is the flocculator agitator is here at this water inlet here. Flocculation chamber is there, if this flocculation chamber, right? The huge tank is there. Then third one is the lamella plate packs here. The inclined pack is there. Then fourth is overflow launders. So overflow water is there, which is taken here. So overflow outlet. So this is the overflow outlet is there. Sludge hopper here. Sludge hopper is there, which is collecting the sludge. Underflow outlet. Okay, which sludge is taken here from this point. And number 8, rake with the drive unit. Okay, at this position the raking unit is there, which is taking this sludge outward. Okay, so the combination can be made. So this is very popular nowadays. So today we have seen regarding the various aspects related with the sedimentation, clarification, okay, and this tube settlers and plate settlers. So nowadays these are becoming very popular in all the units. So thank you very much for joining this session.